Hey there, and welcome. Today, we're diving into a technology that could totally get rid of one of our biggest daily headaches and, power our entire future in a completely different way.
I mean, just stop and think about that for a second. What if you never had to scramble for a phone charger again? Or, change the batteries in the TV remote? This isn't just some sci-fi fantasy. It's the actual promise of a technology that literally powers things from the air around us.
And believe me, we are absolutely going to need it. Because the future we're heading towards, it's not just about billions of connected devices. No, we're talking about trillions. Trillions of tiny sensors everywhere, in our clothes, on our food, inside our buildings. And let's be honest, there's just no way our current batteries can handle that kind of scale.
And that right there, that brings us to the heart of the problem. You see, this grand vision of a super smart, totally connected world, it's kind of hit a roadblock. And that roadblock, well, it's made of millions and millions of tiny little batteries.
This whole idea of connected gadgets isn't exactly new. It actually started way back in the 80s with, of all things, a Coke machine at a university that could report if it was empty. Kind of fun, right? Then, in '99, the term Internet of Things gets coined, thanks to those little RFID tags. Fast forward to the 2010s, and suddenly our homes and our wrists are just flooded with smart devices, and every single one of them needs a battery. And that's the kicker. That complete dependence on batteries, it's turned into this huge bottleneck. It's the one thing holding us back from what could be.
So the big question is, how do we get around this problem? Well, the answer sounds like it's straight out of a movie. We figure out how to pull power from thin air. And that, my friends, is exactly where Ambient IoT enters the picture.
So, Ambient IoT, what is it? It's basically a whole new category of devices. These things are totally self-sufficient. You never have to plug them in. You never have to change a battery. Why? Because they're constantly sipping on the tiny bits of energy that are already floating around us. Like the radio waves from your Wi-Fi router or your cell phone.
Okay, so this is where it gets really cool. How on earth does a device actually scavenge power from invisible waves in the air? The science is pretty mind-blowing, but it all boils down to two main concepts.
All right, idea number one is something called energy harvesting. This is the absolute foundation of it all. It's literally the process of grabbing energy that's just out there in the environment, energy we don't even think about, and it converts that into usable electricity for a device. And you'd be surprised where this energy comes from. You can get it from light, from heat, even from tiny vibrations. But the real game changer for Ambient IoT, the big one, is that massive, invisible ocean of radio waves we're all swimming in 24/7. I'm talking about Wi-Fi, cell signals, TV broadcasts, it's everywhere.
So how does this magic actually happen? It's all thanks to this brilliant little component called a rectenna. Think of it, part rectifier, part antenna. It's like a microscopic windmill, but instead of catching wind, its antenna grabs those radio waves. Then, a tiny circuit converts them into a little trickle of DC power, just enough to wake up a sensor and make it do its job. And get this, because you can basically print these things on flexible material for next to nothing, you can start to see how we could realistically get to trillions of them.
Okay, so that's the power part. The second piece of this puzzle is, how do they talk? A normal device like your phone has to shout by creating its own radio signal. That takes a ton of energy. But an ambient IoT device, it does something way cleverer. It just reflects. It basically catches an existing Wi-Fi signal and then tweaks how it bounces back, using that reflection to send its own message. The analogy is perfect. It's like using a little mirror to flash Morse code using someone else's flashlight. It's brilliant, and it uses practically no power at all.
So, okay, you take this super clever energy harvesting and you combine it with this nearly power-free way of communicating, and suddenly you start to unlock a future that looks radically different from the one we're living in today.
Just imagine this, a milk carton with a tiny sensor printed right on it, powered by the Wi-Fi in your kitchen. It could send an alert to your phone the second the milk is about to go bad. Think of all the food waste we could prevent.
Or how about healthcare? A disposable smart patch you just stick on your skin. It could constantly monitor your heart rate, your temperature, all your vitals, and send that info straight to your doctor. And you'd never, ever have to worry about a battery dying. And we could think even bigger. We could embed thousands, maybe millions of these little sensors into our infrastructure. A bridge could literally tell us if it's under stress, giving us a heads up about a potential problem years before it becomes a disaster.
So yeah, this is not some niche tech for nerds. The impact here is going to be huge across pretty much every industry you can think of. In agriculture, you could have sensors telling farmers the exact spot that needs water. In retail, you could have smart shelves that always know their inventory, down to the last item, in real time.
Okay, so this all sounds amazing, right? But let's be real for a second. It's super important to have a balanced view here. We are not quite there yet. There are still some pretty big hurdles we need to clear.
And that brings us to the main trade-off. The promise is huge, right? Trillions of devices, zero maintenance. But the reality check is that the amount of power these things are harvesting is tiny, like really, really small. So that means the devices can only do very simple jobs. It also means they have to be pretty close to a power source, like your Wi-Fi router. And their communication speed, it's way slower than what we're used to.
So right now, engineers are working like crazy on these problems. They're trying to figure out how to be more efficient, how to squeeze out every last drop of available energy. They're also tackling the huge question of security. I mean, how do you protect data from trillions of simple little sensors? And finally, they're working on standards, a common language, so that all these devices can actually talk to each other without creating total digital chaos.
But the vision, the big idea that's driving all of this hard work, it's really powerful. It's this idea of a future where intelligence isn't just stuck inside our phones and laptops. Instead, it's woven into the very fabric of our world, all around us, always on, always connected, and always powered by the environment itself.
So I want to leave you with this question to think about. If you could connect absolutely anything to the internet, and a battery was just never an issue, what would you connect? I mean, just think about it. The possibilities are, well, pretty much endless.